Hi Math 95. I'm going to do a little video to help you go through the Chapter 1 notes. And the way I'm doing this video, I have a 10-minute limit, so I may take a couple of different segments to get us through the notes. But you can follow along, and there will be spots where it'll pause and give you time to fill in the notes or do the questions, and then you can check your answers, okay? Also, if I look like I have paint anywhere, I was painting my daughter's room today, so I apologize. I don't think I got it all off. But I'm going to try to share my screen here. So hopefully you can see these notes. These are the blank notes that are on Lumen for Chapter 1. And we talked a little bit about this in class on Thursday if you logged on there. So we talked about real numbers. Real numbers are the set of numbers that includes lots of types of different numbers. Basically, almost anything you can think of is going to be in the real numbers. And I'll tell you what isn't going to be in just a minute. But for the most part, everything that you see around you is going to be a real number. So you can see we have negatives and positives and decimals and fractions, pi, square roots, all different kinds of numbers. So if you were not here in class on Thursday, I'll just go over this again, these different sets of numbers that are part of the real numbers. So the first one is called natural numbers or counting numbers. And I always say you can think of this as what numbers you would use if you were teaching a little kid to count. If you're going to count their blocks with them, you're not going to start with 0 or -3 or 2.7. You're going to start with 1. So natural numbers are like 1, 2, 3, and so on. And the next set we have is whole numbers. And whole numbers are natural numbers, are included in there, but it also includes 0. I can make this blue again. It also includes 0. So 0, 1, 2, 3, going on forever. So whole numbers, I say you can kind of remember because that O in whole kind of reminds you that there's a 0 there. Okay, so then when we go down to integers, integers are going to include those whole numbers. They're also going to include the negatives. So these start way down at the smallest negative number you could think of, and we go up. So we have -3, -2, -1, 0, 1, 2, 3, etc. Okay, so you might notice that if a number is a natural number, let's say I have the number 7, that's going to be a natural number. That's also going to be in the whole numbers. That's also going to be in the integers. Okay, so each of these numbers can be in more than one set, and that's okay. My example usually is if you have a poodle, that animal is a poodle and a dog, right? A dog is just a larger category, and it's an animal, and it's a mammal. So, it's just part of larger categories. Rational numbers now, this is going to include some decimals and fractions that are in between those integers, okay? So this is going to be a couple things. This could be any number that can be written as a fraction made up of integers. And so I can't have a fraction like -2.3 over 6, right? That's not made up of integers. But if it's a number that you can make into a fraction made up of integers, then it's a rational number. It can also be any decimal that ends or repeats. Okay, so for example, if we have 1.3 going on forever, okay, or if we have something like 2.567, okay, and then it ends, it doesn't go on forever, those would also be rational numbers. All right. Okay, irrational numbers. This is kind of going to be the opposite of rational numbers. So this is going to be a decimal that never ends and never repeats. Okay, so examples are going to be pi. It's quicker to kind of just write it than to find the symbol right at this moment, but you know what I mean, the symbol right up here. Or, for example, something that's in a square root that's not a perfect square. So I'll just copy and paste this one down here. Okay, so something that's in a square root that's not a perfect square. So for example, if I have the square root of 9, that is a perfect square because 3 times 3 equals 9. So the square root of 9 is going to be 3. But if I have the square root of 8, there's no integer that multiplies by itself to make 8. So this is going to be a decimal, and it's going to go on forever. Okay, so let me also just visually show you. Okay, so I'm going to show you on my whiteboard here just visually how these kind of nest together again. So we have our natural numbers, or counting, which again are 1, 2, 3, etc. Okay. Then I move to whole numbers. Excuse me. Whole numbers include all of these. Oops, sorry. I can never remember this right setting, whether it's going to be backwards or not. Okay. So whole numbers are going to have all of those natural numbers in them, but also 0. So these natural numbers are part of these whole numbers, okay? And then I move out one more step, and in addition to all of these, I have integers, which is going to be -3, positive, 0, right? But still no decimals or fractions. And all of the natural numbers and all of the whole numbers are part of the integers. And then we move on to those rational numbers. And these are the decimals that end or repeat, and anything that can be written as a fraction. So something like 2 can be written as 2/1. That's a natural number, a whole number, an integer. All of the integers are also part of the rational numbers. Okay. Now, numbers are either going to be rational or irrational. So our irrational numbers are over here in their own little box. Okay, they don't include any of these. But all of these together, rational and irrational, are part of the real numbers. Okay, now I said I'd tell you the other set of numbers is called imaginary numbers. And that's when you have the square root of a negative number. So this would be an imaginary number. And it's in its own little set. We're not going to talk about those in Math 95. You'll talk about those in Math 120. Okay, so if we go back to the notes for a minute, you'll see, I'm going to pause here for a second. When you look at the notes, the next section is a little checkbox where it's asking you to check off which of those, the numbers, which sets each number is in. Okay, so go ahead and do that, and then you can check your answers. So once you've done that, you can look here and pause the video for a second, and you can check your answers to this. Notice that all of these numbers that we're seeing here are all real numbers, okay? We're only dealing with real numbers here. If we have an irrational number, like this number that goes on forever, it's going to be irrational, but nothing can be rational and irrational, right? And if it's any of these other ones, those are part of that nested set of the rational numbers. So kind of think about that's two different sections. One more down here in the next page. It just kind of got pushed to the next page for me. And this one is the square root of a number that's not a perfect square. So again, that's going to be irrational and also real. Okay, so I'm almost at my time limit for this portion of the notes. We kind of went over a lot of information with this one with the different sets of numbers. The next portion will go over some of the next section, and it won't be as in-depth for some of these sections, but I will see you in the next video for the next page of notes.